All right. So I'm Vi Hart, and I'm here with Sal Khan, and
Hello.
yeah, we're talking about just how we think about numbers and what is the most natural way to think about them in our everyday lives.
And Vi said that she was going to test me right now.
Yeah. All right. Can I borrow
Yes.
the pen?
Yes.
I get to use the official pen and screen. Oh wait,
No, that's off screen.
Okay.
Yes.
Okay.
You need training,
Wait,
Vi.
I need training. Yay.
It looks like a pizza.
It's a triangle.
Right. Where's your test, Vi?
Okay.
You're diverging.
I'm sorry. All right, so here's the number line. Regular old numbered line. No, wait, I want to start at 1. All right, we're going to start at 1. We're going to go all the way to 1,000,000. And I'm going to give you the pen now. And I'm going to ask, where is 1,000?
Where is 1,000? Where's 1,000? I see. I see what you're doing.
So you can think about this logically.
Yes. So I'll tell you what went through my brain. My first knee-jerk reaction was to put 1,000 like right over here. That's what I was tempted to do. Mm-hmm. And then my brain kicked in.
Right.
My highly analytical mind.
Yeah, because there is a correct answer to this problem. We can think. All right.
Because Yeah,
where is 1,000 on the number line related to 1,000,000? Well, a million divided by 1,000
is 1,000.
1,000th.
Right? So it's not there. I was going to draw it like a tenth of the way. No, 1,000 is like there. You barely notice the difference.
Yeah,
between that
you couldn't even see the difference.
Yes.
1,000th.
Let me. So this is fascinating. What is this about? Like why did I do that?
Yeah, why do we think of 1,000th as being much closer to 1,000,000 than it is? And we do this actually all the time. We're not so used to having to think about the difference between 1,000 and 1,000,000, but when we're thinking about the difference between 1 and 2, or the difference between 2 and 3, or 1 and 10, we think, 1 and 2, there's a big difference there. 2 is like twice what 1 is.
Yes, it's twice 1, right.
And the difference between 9 and 10 is the same distance when you're looking at it at the usual scale. It's 1.
Right.
But when we're thinking about real life things, well, the difference between 9 and 10 isn't so big in any real life situation.
No, but the difference between 1 and 2 is huge. In
Yeah.
real life, it's double.
Yes.
Right.
So now we have to think on a logarithmic scale is what it is.
Oh,
yeah.
Yes, the old logarithmic scale. So what you're saying is that we as humans, even though everything we're taught is these linear scales where we want to say, this is 1, and then maybe this is 10, and then this is 20, even though that's where we're taught, and that's what most of our mathematics, we plot lines and stuff like that.
Yeah, that's how we draw it out on paper usually.
Yes.
But that doesn't make sense usually for how we think about things, because the difference between 5 gazillion and 5 gazillion and 10 is
nothing.
Nothing. Whereas the difference between 1 and 10 is huge.
Right. And so that's why almost the multiple matters more than the kind of the distance between the numbers.
Yeah.
Actually, and that's what the logarithmic scale captures.
It is, and that's why we see the logarithmic scale in so many things in real life. As a musician on the piano, we see it on.
Yes.
It's actually the logarithmic scale. So let's get our piano picture.
Oh,
up.
look at that! There's a piano.
Yeah. Okay. Can I have
Here you
the
go.
pen?
Yes.
All right. Let's see if I can figure this out. All right. So here we have this C. Let's call it middle C, and here we have this D. And there's a certain distance between these. And then here's this C and this D. And when we're listening to these notes, we think, all right, they're 1 note apart. This is like the same distance here, between here and here and here and there.
Yes.
But if you look at the actual frequencies, the distances are not the same. This is maybe a bad example because I don't know the frequency of D, but
no, well, we could.
Well, I'll give you an example I can give numbers to, which is maybe the difference between this octave and the difference between this octave, right? If this is C,
call it X, whatever
X.
the frequency is.
Right, yes.
This is like a 440 kilohertz. I don't know.
No, A is 440,
A is
C
440.
is
Well, we call
more
it X.
like, I don't know, let's say 300.
Yes.
All right. So if this is 300 or 300x or just x, then this frequency would be 600.
600, right? It doubles.
It doubles when you go up an octave, and this would be 1200 up here. This C, right? We're in a weird scale here, but all right. So the difference between here is 300, and the difference between here is 600. But when we're listening to octaves, we feel like the difference between this octave shouldn't be half as much as the difference between these two notes, right? The distance from an octave should be an octave, right?
Right. So our sense of pitch is fundamentally the way we perceive pitch is logarithmic.
It's just fundamentally logarithmic. If you want all of these, if you want to have all your notes on the piano be right next to each other, instead of having a piano where you have like one key for C here and one key for C here, and the next C is going to be like over
twice
here,
as
right?
far. Yeah.
And the next C on the piano would have to be like.
So if piano manufacturers they innately made it based on a logarithmic scale, whether they knew it or not.
Yeah, because we think about it on a
They could have made it on a linear scale, and then the keys would just get fatter and fatter as we went to the right.
Oh yeah, fatter keys.
Someone should make that a linear scale piano. Yes.
That would be awesome, and that's not how we think of pitch.
It might be hard to play that. So that's it's just not pitch. It would also even be how we perceive of kind of magnitude of the frequencies, because we have the decibel scale, which is a logarithmic scale.
Yeah. There's a lot of natural, intuitive logarithmic scales. So when we're looking at how loud something is, that's also all right. The difference between how I'm talking now and how I'm talking if I'm a little louder, and that's gonna be, we feel like distances between loudness also.
Are right. We perceive it a lot. It is harder to explain.
I don't have any pictures of how loud something is.
No, and we don't want to bother people by just getting louder and louder.
Screaming.
Yes.
Yeah, I can scream at you some more. It would be great.
Right. No, but that's fascinating, especially this little game here. I mean, this is where I'm going to start doing this at the next party I go to.
It's good, and it makes sense when we're looking at things. The difference between how much $1 million and $10 million is.
Yes.
Just the world follows these kind of rules.
Right. Very cool.
Yeah.
Awesome.